Hi, guys. Now it's Friday for you, and hopefully all has gone well. Hopefully you did well on the quiz. And oops, come back here. And you had a chance with your partner to go over that AP question. Let me push F5 here. And now we're going to start a little bit more notes on the rest of section 2. Okay. I'll grade your quizzes when I get back. Sorry, I won't be able to pick them up till Monday. So maybe on my prep periods Monday, I can look them over. We'll see if I have time. Okay. But let's see how we can do with the rest of the content on our means and variances for our probability distributions. All right. So now it's going to get a little hairy, a little bit of formula and stuff, but hopefully this will start making sense to us. For our probability distributions, if we have two separate distributions, X and Y, okay, the mean of adding those two together to make one new distribution would be the same as the mean of each distribution added. So you can see here the sum of the means is the mean of the sums. I said that backwards and it's written, but the mean of the sums, so that's what this is saying right here. The mean of the sum of the distributions is the same as taking each mean of each distribution separately and adding them. If you were to subtract two distributions, then the means would also be subtracted to get the mean of the combined. Okay. You'll have a third situation where you might take something plus something times all of the numbers in your distribution. If that's the case, then your the new mean, is going to be that value A plus B times that. Okay, so the mean is going to move exactly how the rest of the data set has moved. But for variances, that's not the same thing. So this is only works if your variables are independent. Okay, that's super important to know. If the variables aren't independent, this will not make sense. But if you're going to get the variance of the sum of the distributions, then you can just add the two variances, just like we did with the means. This one's pretty straightforward. However, the difference of them, you're actually going to be adding the variances, not subtracting them. Because remember, we're squaring things here. What happens to -1 when it is squared is it becomes +1, okay? So this is plus here. Me needing to remember these situations here, and you're going to practice that in just a minute. The variance of a plus bx is also weird because it's just going to be b squared times the variance of the x. If you recall, when we're taking our mean, adding a constant to the entire data set just moves the data up vertically, but the variance, the change within the data does not happen, okay? So that's why it says here, adding a constant to a random variable changes its mean, okay? But it will not change the variance of the data because A just moves that data all the way up vertically, but the difference between the points is still the same, okay? So try to wrap these little formulas around your head. I think what we're going to do is practice with them. That's the best way to do this, okay? So for example, if you know the standard deviation of one probability distribution is 3 and of another is 4, and you need to find the standard deviation of the combined probability distribution x plus y, then you can find variances squared, standard deviation squared is 9 and 16 for each. And then you simply add 9 plus 16 to get 25. Okay, remember then you're going to take the square root back of that and get 5. Okay, so be very careful. Notice we did not add standard deviation of x plus standard deviation of y. We have to move to what we know about variances, add those, and then square root again. Okay, so 9 plus 16 is 25, and take that square root. This is really tricky. A lot of students try to add these, and you won't get 7 here. Your standard deviation of the combined is 5. So please remember to go to your variance first, and then back to standard deviation. So let's look at another one. Here's where you know your means of two separate distributions and your standard deviations. And so the mean of x plus y is going to be just the means added. Okay, 20 plus 16, 36. Good. The mean of subtracting your two distributions is going to give you the means subtracted, which is also 4. And then your standard deviation. So let's look at this again. This is like going back to the beginning. You have to go to your variance first. So you take your variances of each, your standard deviation of each and square it. So that's where I get 25 plus 49. And then take the square root again. Please do not add 5 plus 7 to get this. Okay. And then here's a situation where a z, probability distribution z, will be taking all the values from x, timesing it by 4, and then adding 5. You're given the mean and the standard deviation here. So to find the mean of z, you're going to do 5 plus 4 times the mean of x, which will be 85. To find your variance, you're going to do b squared times sigma squared, which is 16 times 25 or 400. And then, of course, to find your standard deviation is that 220. Now, another way to find the standard deviation, you don't have to go all the way through the variance and square root. You can take that 4 times the 5 to get this. Okay, you can do b because it's just the square root of this. So you could do b times the standard deviation of x and have 20. Okay, I just went the long route to show you what the variance is and then the standard deviation as well. Okay, so that's where I said if you're just finding the standard deviation, the easier way is to just take 4 times the standard deviation. Okay, one more example on this slide, 7 plus 3x. So the mean and the standard deviation are given to you. Okay, before I go on, see if you can figure out what would be the mean of z. Okay, and what would be the variance of z? And then finally, what would be the square root of z? I'm sorry, the square root of your variance, which would be your standard deviation of z. Okay, let's see what you figured out. Your mean is just going to be 7 plus 3 times the mean. So that's 22. Hopefully that's what you got. Your variance is going to be b squared times the variance. So that would be b is 3. Well, in this case, they're both 3. So 3 squared is 9. And your sigma is 3 squared is also 9 for 81. And your standard deviation would then just be 3 times 3. This 3 times that 3, which is 9. Okay. Phew. So you have this to look back on if you get home to doing homework and forget some of this. Okay. All right. Now let's take a look at what this is with a normal distribution. Comparing normal random variables is also going to be normal. So we can use the same rules as we used for discrete. So I want to just do a little example here. Here's a combined portfolio. Portfolio is where you buy stock in all these: Apple, Google, Starbucks, Microsoft. And I just labeled them X, Y, Z, and W to be our probability distributions. Here's the mean profit, average profit for each of these stocks, and the standard deviation of them. But you're going to do a combined portfolio of all these, and you want to find your mean of all these. Now, if you were to talk to each other about this, what would be the mean average profit of your entire portfolio? And then let's find out what the standard deviation is of that entire portfolio. Okay. So yeah, as you're thinking on that, here come the symbols for Google and Apple and Starbucks and Microsoft. Okay. All right. So I left that little chart up here for us. Let's do some thinking. Starbucks predicts this year's profit will be at least $225 per share. So how likely is